So today we're dealing with arithmetic sequences, and by the end of the lesson we'll be able to recognize arithmetic sequences and write recursive and explicit formulas for those sequences. Okay, so first of all, what is a sequence? Well, a sequence is just a string of numbers. A sequence is just a string of numbers like these below. -4, 1, 6, 11, 16, and dot 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 just indicates that it goes on forever and ever. Then I have 1, 1, 2, 3, 5, 8, and that one also goes on forever and ever. Those are both sequences. Okay? And you can tell that there's a difference between the sequences. In the first one, you can probably see that right here, if I add 5, I get from -4 to 1. And then I do +5 from 1 to 6. +5, +5 each time. And then if I did +5 again, my next number should be 21. And then +5 again, I would be at 26, and then 31, and I could keep on going with the sequence as we just discussed. That's an arithmetic sequence. Sequence in part A is arithmetic, because the difference between each term and the term just before it is 5. 6 minus 1, 1 minus -4, 11 minus 6, 16 minus 11. They're all equal to 5. That is called the common difference. Common difference. Okay. Now, there's different than the second one. The second one is not arithmetic because the difference between the terms is not constant. In other words, 1 plus 0 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2, and then 5 plus 3 to get to 8. Okay. So that's a different type of sequence, but it's not arithmetic because the differences, these differences are not the same. 0, 1, 1, 2, 3, and that just, okay, and it goes on forever and ever. Alright. By the way, this is a sequence called the Fibonacci sequence. Okay. And it's a well-known sequence that you might want to look up, and you can probably already just determine a pattern and maybe have determined what the next one would be. All right, sequence notation. Sequence notation, we usually use U, so U sub n would be the nth term. In other words, U sub 4 is the 4th term. Okay, U sub 2 is the 2nd term. And then two important ones, U sub 1, of course, is the 1st term. We're going to need that. And sometimes we use U sub 0 as the 0 term. And you might say, why would we have a 0 term? Well, sometimes we want to know the value of something before we start, adding or subtracting things from it. So for example, if you have a loaf of bread, you might want to know how many slices there are in the loaf before you start eating them. Before you just start deciding how many sandwiches you can make. You kind of have to know that. So U sub 0 would be the number of slices of bread before you took any out. And then one that sometimes causes a little difficulty, U sub n minus 1. This is the term before U sub n. Now kids always balk at that, but if I say U sub 5, you automatically know U sub 4 is the term that comes before it. And then U sub 3 is the term that comes before that. But aren't you just doing 5 minus 1 and 4 minus 1? So then U sub n, term that comes before it, we follow the same pattern. It's U sub n minus 1. That's what we did. We did 5 minus 1 to get 4. We did 4 minus 1 to get 3. And when we have a sequence, we like to be able to create a formula that can tell us how we get anywhere. And there's two types of formulas. Our first is called a recursive formula. Okay, and it'll go back to what we talked about when we first did that original sequence where we were adding 5 each time. So the formula is this: U sub n equals U sub n minus 1 plus d. And d is that common difference between consecutive terms. And then you must also include U sub 1 is the 1st term. Okay, you must include that. Okay, you got to, because If you don't, you're gonna lose points, and you're going to not really give a description of the sequence, and I'll show you why that is in a minute. So let's write a recursive formula for that first one that we looked at. So we already said that our D is plus 5. We're adding 5 each time with that sequence from before. So our formula would be u sub n equals u sub n minus 1 plus 5. In other words, if I want to find the nth term, take the term just before it and add 5. So u sub 1, 2, 3, 4, 5, u sub 6 should equal u sub 5 plus 5. Well, u sub 6, this is u sub 1, and this is u sub 5, and the rest are in between there. So u sub 5 is 16 plus 5, which is 21. So u sub 7 would equal 21 plus 5, because now we know u sub 6, and u sub 7 is u sub 6 plus 5. So that's 26. And u sub 8 would then be 26 plus 5 is 31. So each time we get our answer, we can find the next term, we keep plugging in that answer there. 21, we got u sub 6 was 21 by doing 16 plus 5. And then to get u sub 7, we had to take that 21 and add 5 again to get u sub 8. This should be an 8. Okay. But now that's all well and good, but what if I want to find u sub 761? Well, I do know that u sub 761 in this particular case would equal u sub 760 plus 5. But I don't know u sub 760, so I'd have to find u sub 759, but then I'd have to find u sub 758, and I could keep going, and that would be a lot of work. Okay? So we're going to have a way where we can bypass that and make it a lot easier. By the way, the last thing we have to do up here is u sub 1 is negative 4. That is the whole thing. That is our recursive formula. You might say, why do we have to have the u sub 1? Here's why. Suppose I give you this. Now if you look at that sequence, this is, I'm adding 5, and then I'm adding 5, and then I'm adding 5, and then I'm adding 5. So in other words, u sub n equals u sub n minus 1 plus 5. It has the same part here. And so, but here, u sub 1 equals 2. Okay. The u sub 1, it allows us to tell the difference between this sequence and that one. There are lots of sequences I could have where I add 5 each time, but if I don't know where to start, it doesn't tell me what the sequence is. Okay? So that is the recursive formula for an arithmetic sequence. It's just u sub n equals u sub n minus 1 plus 5. It could be minus 10. Okay? It could be plus negative 3. Though that's an arithmetic sequence. All right. Now an explicit formula. This is where it would be nice to be able to take and not have to do u sub 759 and then u sub 758 and so on. An explicit formula is going to allow us to avoid that. Okay? And here's an explicit formula. If you think about, if I want to go from u sub 1, in this particular formula u sub 1 was negative 4 and u sub n was that u sub n minus 1 plus 5. Well, if I want to go from u sub 1 all the way to u sub 761, I have to add 5, add 5, add 5. How many times? Don't I have to do it 760 times? And that would get me from u sub 1 to u sub 761, right? So, well then, repeated addition, if I'm going to do it 760 times, wouldn't that be 760 times 5? And then I started at negative 4, So I would take negative 4 plus 760 times 5, which, let's calculate that a minute. It would be 760 times 5, okay, so 3,800. So I would take negative 4 plus 3,800, which is 3,796. So U sub 761 in this particular case would be 3,796. Well, that's a lot easier than having to add 5 all those times and having to know each term in the middle. That way we go right from U sub 1, we skipped over all those terms to get right to U sub 761. That's what an explicit formula does. And you can see right here, U sub n equals U sub 1 plus d, that common difference, which of course was the 5 in this case, times n minus 1. Well, so if we use this, U sub 761 equals U sub 1 plus d times 761 minus 1, which of course is 760, right? So U sub 761 would equal negative 4, that's U sub 1 is negative 4, plus d is that 5 times 760, which we just discovered right here. So we said that was 3,796. That's an explicit formula. It allows us to pick out any part of the sequence that we want. Alright, so here's another example. For the sequence 22, 19, 16, 13, we want to write a recursive formula, an explicit formula, and then find the 452nd term. Okay, so here's our solution to that. A, recursive formula. We have to know d, which it looks like these are going down by 3. So d is negative 3. So my recursive formula is just U sub n equals U sub n minus 1, and then either plus negative 3 or minus 3, either way is acceptable. And don't forget, we also have to say U sub 1 is 22. Okay, so that's our recursive, remember? Okay, now for b, we want to write, it's the same, d is the same, but our explicit formula is U sub n equals U sub 1 plus d times n minus 1. Well, U sub 1 is 22 plus negative 3 times n minus 1. So there is our recursive, right? And here is our explicit. And then for C, find the 452nd term. Well, we just plug it in to B then. It would be 22 plus negative 3 times 452 minus 1. Okay. And you can do the math for that on your own. Figure out what that would be. Okay. Okay. All right. So one last example here, and then we're done with this part. In an arithmetic sequence, U sub 6 equals 62 and U sub 12 equals 104. We want to write an explicit formula, a recursive formula, an explicit formula, and find the 452nd term. Okay. Well, this time they don't give us a U sub 1, and they don't give us a D. In fact, they don't even give us 2 consecutive terms. These terms are apart. Well, if we understand that if we want to find a common difference, it must take 6 steps to get from 6 to 12. So if we take 104 minus 62, that would equal 42. And we take 12 minus 6, this one and this one, right? And that is, of course, 6, and 42 divided by 6 is 7. So D, that's D. Because if we go up 6 times, we go up 42 times. So we subtracted the 104 minus 62, and then we divided by how many steps there are in between them. Because all the steps have to be the same amount. So each step has to be 7. And when I took 6 of them, that would get me 42. So then my recursive formula would just be u sub n equals u sub n minus 1 plus 7. And u sub 1, we would have to determine what u sub 1 is. Okay. But it's also acceptable just to put one that you know. We know u sub 6 is 62 and not put u sub 1 this time. We know u sub 6 is 62. Could we figure out, and we just let other people figure out what u sub 1 is? That's actually acceptable. Okay, that's actually an acceptable way to go. Now, the second part. B, write an explicit form. So it'd be u sub n equals u sub 1. Now we have to figure out u sub 1 because we can't not figure out u sub 1 because we need it. So let's figure out u sub 1 here, which is if I'm going from u sub 6, I would subtract 7 5 times because I'm moving backwards now. I'm going from 6 down to 1. So that would be 62 minus 35, which is 27. Okay, so u sub 1 is 27. So we do u sub 1. This is the formula, of course. So it would be u sub n equals 27 plus 7 times n minus 1. That would be our answer for B. And then for C, we simply plug in the 452. So u sub 452 equals 27 plus 7 times 452 minus 1. And again, I'll let you put that into your calculator for yourself and get the answer.